Hi, my name is Mike and I will guide you through the video. The goal of the video would be to explain how this ventilation system will be designed and also the calculations will be done. First of all, let's start with the load calculation. To start the load calculation, it is necessary to insert the location of the building to know the outside temperatures for cooling and for heating load. The second step is to create the room books, and there are different versions to do this. The simplest way is to use polygons existing in a 2D drawing. We activate the function, select the polygon and insert the values of the room like room number, name, description, height, and so on. This can be done for all of the polygons, so I get as a result a room book per polygon, so one room book per room. To visualize and to check the values, you can use a dialog called Room Manager. This Room Manager will give you a representation inside the model, and depending on the different used colors, you can see if a wall type is defined as an external wall or an internal wall to have an easy functionality to find out if you have made mistakes. As here in these two corner rooms, the outside wall is yellow, I know it's an internal wall. By using different styles, you get different visualizations, so it's easy to handle. For different rooms, I want to change their properties, so a change might be the room temperatures from the toilet areas to a higher level, and also for the staircases and for the corridors to a lower temperature level. Additional visualizations are available, for instance, for transmission loads, for specific U values, or for room temperatures or specific watt per square meter values to see what is the specific load of a room. If anything is highlighted in a red color, you might know there must be a failure. Let's switch to the cooling load calculation. The room is still the same, but we have to define the different values for cooling load. So we need to add maybe other room temperatures, number of persons, and also the occupancy time for the room. As well as we have to insert internal loads like computers or machines or notebooks or whatever the heat is producing inside the room. In this case, two notebooks with a single performance of 350 watts, so in summary it's 700. Now we can use the load calculation, and in this case especially the cooling load calculation, to calculate the flow rate for our air ventilation grills. So I select them from the catalog to have a representing block, select the size, and switch the calculation. As a result of the cooling load calculation, we can see the sensible and the latent load of the room, and this is calculated back into a flow rate of 544 cubic meter an hour. By raising the number of grills, maybe to 2 or to 4, the performance per grill will be lowered, so you can decide the correct flow rate for the correct grill. This also can be done for all the rooms. So as a result, at the end, you have 1 or 2 or 3 grills inside the room. Let's deal a bit with the layers, so switch off a layer and go further with the easy-line system. Every easy-line system needs a starting point at the beginning, elevated to the height of the ductwork, maybe here in this air handling unit room. Now let's add the path for the ducts. Therefore, you need to draw lines, because lines are used as a basic for the entire system. Go a bit forward, a bit down, and restart here to finish the system. The next step will be to connect the elements. So I select the grills, confirm to the line. Can be done in plan view, can be done in isometric view. You only have to select always the connection function, the grills, and the line. The last step of ECLN is to calculate the system. So you decide what should be the result, in this case the 3D model, select the ductwork or the line work, and get a result. As well as you get a 3D model, you also get a 3D calculation. If you want, you can switch it off and on, depends on the settings. Also here, you have the possibility of different representations. So we're switching the visual style from a wireframe to an X-ray mode. It is fulfilled, and you can use visualization function of AX3000 to visualize the results. So in this case, might be the friction, pressure loss per meter duct. So depending on the color, you can see if it's on a higher or lower friction level. While switching to velocity, you can see the velocity at the beginning is somewhere around maximum 5 meters a second, at the end maybe 3 meters a second. And you can switch it off to be back in the beginning. The main power of AX3000 is to give you a quite simple way to calculate different variants of a system, of different versions of a system. Because of the changed variant, you get different colored ducts in the visualization, and you might find problematic situations if the velocity is too high or the friction. Or we're switching other values. There are some other opportunities, so we go back with the velocity, but we want to have might be more round pipe. Not only the last pipes should be round, also maybe in the middle somewhere. So we have fixed the maximum pipe diameter to something around 300 millimeter. Recalculate, confirm, wait a few seconds, and you get a different result of the system. Let's switch off the visualization and take a look for a few different variants. So while dealing or playing with the velocity and the connection diameters, you can see different variants of one and the same system. So on the left side, maybe few connections of one subline. So at the end, it's ending some at the lowest picture with a T-piece, in the middle with a special fitting, on top with a straight duct and two directly connected elements. And then on the right side as well, you can see a few different variants of the same connection, only by switching or playing with the parameters of the system. Recalculate to get back to a rectangular duct. Work with two viewports. And continue with another version of drawing. It's called construction. I have switched on a few layers because this air handling unit and a few ducts are prepared, and I will continue the construction while starting on this flexible nipple, going straight to the wall. So it is enough to select the wall directly in the plan view or in any other view. I decide to change the layer to the same layer as this duct, and I want to have an elbow in an offset of 100 millimeter going upwards, so I can flip the orientation and inserting all the values directly in the catalog. I select the upper surface of the duct to define the vertical elevation, change the orientation of the elbow, and start from the elbow, go to the duct to connect them. It's still connected automatically depending on the location. Depending on the cross sections, the software can do this automatically. And last, we want to add some fire damper, so one element. So also here you have functionalities to select any block. So this database can be enlarged. Select the dimension, select a duct line. You want to insert it, move it forward or backward to the correct position, press one point, and then the fire damper is added. Last but not least, bit of labeling or annotating. So I select the duct. I've selected one labeling or annotation element. This is an associated function. So if the duct system is changing, also the label will be changed. And so I can see some kind of track numbers. So the connection between the drawing and the calculation. I can see flow rates, velocities, as all other values you have decided to be visible inside the block. At the end, I use some kind of automated function to see the dimensions inside the ductwork. I select the ductwork, I confirm, and then it's highlighted automatically on any connection if there's a change in direction or change in size. A mass list or a fitting list to order the produced elements. And so we are at the end of the presentation. Thank you for your time, and maybe hear or see you in the next video.